Thank you, Cooper. We can solve two-step algebraic equations. First vocabulary is like terms. Terms that have the exact same. The parts we're talking about are.
Variables and exponents.
Does 2x and 4x have the exact same parts?
Yes.
Therefore, we can combine to make.
6x.
Does 3x squared and 5x squared have the exact same variables and exponents?
Yes.
Therefore, we combine to make.
8x squared.
Does 3x squared and 4x have the same parts?
No.
Have you been combining like terms for your whole math life?
Yes.
Excellent. And distribute means to go.
Spread means multiplication.
So normally on a problem like this, 3 times 2 plus 6, we do order of operations, we do the parentheses first and multiply, right?
Yes.
But we can actually think of this as distributing the 3 through to the 2, so 3 times 2, right? And then adding 3 times 6. Yes, no? We get to the exact same answer, which is 24. In combining like terms, for 3, 4, 5, and 6 here, we followed a process. We followed a two-step process. Our first step was to do what?
Code.
And our second step was to?
Combine like terms.
Now on number 3 and on number 4, we didn't really code because there wasn't much to code. It was pretty quick and simple. 3 we could combine, 4 we could not. Number 5, things got a little bit more complex. We had a 7xy and we had a 2xy that we could combine together, right?
Yes.
So we got what? We see that we coded a negative 12, which is a constant, and nothing else went with it, right? So we just left it as negative 12. And then we also saw that we had a 4x squared y, a negative 4x squared y. Did anything go with that? No. So we kept that by itself here. Number 6, a little bit more complex. We combine, I'm not going to go through the whole thing, we combine all of the red circles to get negative 3. We combined all of the black squares to get negative 2m. And we combined all of the green triangles to get negative 1m. Just to check, is negative 1mn the same thing as negative mn?
Yeah.
We can have that negative 1, but it doesn't need to be there. Because we're literally talking about negative 1 of these things. Negative 1 of these mn's. And then number 7. We started off by just solving two-step algebraic equations on 7 and 8. Look at number 7, please. The problem's in blue. What's being done, or what's our goal? What's being done to the variable?
Addition.
It's being multiplied by 2 and it's being added by 4, right?
Yep.
So we decided we wanted to get rid of the adding 4 first. Why?
Because it's easier.
The easiest step is to just get rid of the addition or subtraction, right?
Yes.
So to get rid of addition, we subtracted. And then we were left with this right here, yes, no?
Yes.
Is the variable alone?
No.
What's being done to the variable?
Multiplication.
How do you undo multiplication?
Addition.
And we got x equals 4. Number 8 is no different. I'm going to skip down to number 9. Number 9. So in blue again is negative, or 60x minus 40x minus 20 equals 20. Why are 60x and negative 40x circled? They're like terms. So 60x and 40x really is the same as what?
20x.
So we rewrote the problem as 20x minus 20 equals 20, and then we solve for x. Last problem we did, 4 times x plus 6 equals 48. What did we do first? We distributed the 4 to the, and the 4 to the, what's 4 times x?
4x.
What's 4 times 6?
24.
It's equal to 48, right? What's being done, or what's our goal?
Give the variable.
What's being done to the variable?
Multiplication.
Everybody, what's being done to the variable?
Multiplication. Addition.
What's easiest to undo?
Addition.
The addition is the easiest to undo, Riley? Is it? Eyes up here? The addition is the easiest to undo. That's why your eyes are up here. So once we undid the addition, we still had 4x equals 24, right? Right?
Yes.
How do you undo that?